Let's fill up my full face here. Hi, I'm Tom, I talk about code. Today we're doing even more Rust macros. Last time we had a really successful stream. We generated a lot of code using macros. Eventually I worked out that if you're doing procedural macros in Rust, quote is just kind of magic, it just kind of works. Today we're going to go even further with that. We're going to generate even more interesting code that depends on, well, we'll see. Let's get into that fairly quickly here. So, let me quickly link my live stream to my wonderful chat out in Discord. This one. Oh, and it sounds like my audio is good, so that's a good sign. Cool, but yeah, so we'll have a quick look at what I did last time. It was good. It was good. Announcements. Alright, there we go. There we go. Cool. Let's let that sit. So, last time we wrote this fantastic macro that means that we don't have to care about all the tedious work we were doing before when generating, well, I mean, there's still some of this tedious work. So, we define our instructions, we use this derive macro, and now all of the logic for converting these into, you know, the kind of 8-bit operator and back is just magic. It just happens. It's just there. Also reading them from string and back. So when we use our assembler and we grab, where is it? When we grab an opcode from a string, this now just magically happens based on this derive, which is really good. It's amazing because this was really fiddly and really easy to get wrong, right? We had to manually write out the names of all of these things and then map them into, you know, what they should correspond with. That's not good. I'm also using an attribute here as part of this derive macro to define what the actual 8-bit value of each instruction should be, of the opcode of that instruction should be. So what appears in this opcode attribute is what goes in these bottom 8 bits of the instruction. Okay, but we still have a bunch of tedious stuff that's happening here, right? For example, to encode an instruction into, well, to encode an instruction, right? Our instructions are 16 bits long. To encode one of these instructions, we have to do this tedious work. We have to do a bit of bit manipulation. So we get the opcode, and then we OR it with whatever data needs to go in the remaining 8 bits. In the case of something like NOP or a pure stack operation, that's nothing. We just have the opcode as an unsigned 16. In the case of push, it takes one 8-bit number, so we have to encode a number into the instruction as well. Push register and pop register take one register, which get encoded, and then add register takes 2 registers that have to be encoded. Mr. B in chat is from Iran and loves my videos. Wow. I don't think I've had an Iranian viewer before. Welcome to the show. Cool. So, the idea is going to be really simple. This code, so you can see, right? Push register and pop register, the code is the same for how the arguments, I guess, the arguments to the instruction get encoded. It's just the opcode that's different. So what if we look at all of these types, right? Or the types that get, I guess, is this the discriminant of the variant of the enum? Is that what it's called? The types that are part of this variant, right? The data that's part of this variant. And that's actually going to determine how they're encoded and decoded. And so we can use a macro. We can look, we can say, okay, well, in the case of NOP, there's no fields in the enum. So NOP just would get encoded like this. We can look and see that they either have an unsigned 8, a register, or 2 registers. And maybe we can add more instruction encodings in the future. Maybe we can add more types with more meaning. But for now, these are the 4 instruction formats we're going to have, and by pulling these apart at compile time, we can automatically generate this code. And the same thing is going to happen for the decoding logic, right? In the case of something like NOP, we map the opcode straight into the instruction. There's no extra data that needs to be there. In the case of add stack, there's no extra data that needs to be there. In the case of add register, which takes 2 registers as arguments, we have to decode these registers. But this is going to be exactly the same work for every single instruction that takes 2 registers. So rather than writing this every time, say we have subtract, say we have multiply, although I'm not sure if I'm going to have a hardware multiply, you know, it's all just determined by the type information, and we can know that at compile time. So let's do it. Let's dig in to our macro code And let's stretch this out a bit further. So we're generating this opcode enum. Now, if you're a smart person, you're probably looking at this and thinking, isn't this almost just an internal detail now? And you would be correct. The existence of an opcode has almost entirely been shifted into this op file. Our assembler still pulls this in and still uses it in a few places, but I'm pretty sure that, I mean, again, this can probably actually be auto-generated, which is funny, but I don't know if I'll do it. Okay, but yeah, this is kind of taking the encoding and decoding. I mean, in this sense, right, this is like taking a string and mapping it into an instruction, whereas we're just thinking about over here, mapping the 16. I mean, maybe this can we should actually auto-generate this too, but because this is like an onion, right? We're peeling this out one layer at a time. But once we get rid of this, I think opcode actually can be completely factored out within the macros. But anyway, we're gonna generate this. We're gonna generate this. So we're gonna have our impl instruction block in a macro file. So implementing things for opcode. This is getting to be a very long quote, which is quite a lot. It's a lot to do with, but it should be okay. Okay. Now, critically, we don't have a default case here, so we need to be careful that we actually generate enough of the right things. Nice. Quote. Does this quote get properly closed still? It looks like it. What does this close? This. That was too many. Bobbius, good morning. How's it going? How's it going? It's always good when I can see familiar faces making these streams. Okay, that is the correct number of curly braces. So, to generate this, I think I'm probably gonna do a very simple thing. Maybe. Ugh. So, I guess we can say, what is this? So it's gonna look something like this, right? It's gonna be like this. Self. So each of the field names in this case being this should probably be called variant names, but we'll go with field names for now. And then this is gonna be some kind of like field U16 encodings. And this will actually just be, so this will be a vec of the result of calling quote, and we'll see this in a sec. So field names are all the names of all the identifiers of the variants. Field values are what the opcode attribute is for each of these variants. What did I call this? Field U16 encodings. Let's do it. U16 encodings is going to be a vec of something. AST variants iter map. Okay, so for each variant, we're going to do something. And it's going to be good. And it's going to be real good. Okay, here we go. We're going to be smart. I'm going to have to pull up the docs again. Item enum. Is it enum item or item enum? Item enum, perfect. Okay, so this is what we've got, right? We've got this enum item. It has attributes, it has visibility, it has token, identifier. Wait, is this right? Is this what I'm playing with? AST variants. Yeah, this is right. Because we have adders, we have this stuff. Variants, yeah, variant. So each variant adders identity discriminant. Now, discriminant is apparently not what I want. Fields is what I want. Unnamed, yeah. So fields. Okay, unnamed. Fields unnamed, which is well, I don't know what parent token is, but that's oh, parent token I guess is literally the like wrapped in parentheses. That's cool. That's cool. Punctuated. That's fine. Sorry, I want the actual field. And this looks very similar to what we've seen before. So this is good. This is good. So and then, so is it the identifier? It's the type. It's the type. We would expect them to. Oh yeah, option, right? It's optional. So an unnamed field will not have an identifier, but it will have this type. So we need to grab the amount of types and what those types are. So okay, okay, x dot fields. So let's say if let unnamed So we unwrap the unnamed fields only if they're unnamed. And then, can we iterate this? We can, okay. So, fields let types. We'll grab the types out of this. So this is fields.unnamed.iter.map. We're going to map each field into its type. If types, if there are no types, do we match this or do we compare? Damon, welcome, welcome. I know if there's a Rust stream, I can count on you rocking up. Let's fix this indentation because that's annoying. Okay. So if there are no types present, then we can just return this maps into. Now this is actually kind of tricky, right? Because we need the name here as well. Okay, so what we actually need to do is not overload the name. Actually, no, that's fine, that's fine. So we have x. So in this case, x is our variant, and we can grab the name from this, right? x.ident. So opcode we can grab the identifier opcode name as u16. And actually we don't even need the comma. Okay, I think this is good. I think this is good. So that's it. That's all we need here. That's all we need here. Now, and actually this is probably going to be the last statement in the block, so we don't need a return. $YYY says, learning a programming language by working on such a complicated project, nothing but admiration, thank you. Like that, oh my gosh. There's nothing inherently complicated about a 16-bit virtual machine, but doing it with macros and stuff like this, oh boy, this is a crash course in Rust, but it's good. It's rusty Rust. My only doubt, like the only thing I'm disappointed about on this whole project so far is that I haven't had to write a single lifetime, right? Because of the way a virtual machine is structured, it's very like top down, if that makes sense. And the lifetime of everything is very upfront. Very straightforward. So Rust has just been able to infer it, so I haven't had to struggle with manually annotating lifetimes, and I'm a bit let down. I was promised that Rust was going to be this horrible experience. I was constantly going to be fighting the borrow checker and writing lots of single quotes. But no, that hasn't delivered. So honestly, like Rust, it's been a bit of a scam. Okay. if we have one type, maybe if the first type, oh my gosh, this isn't what I wanted. Is there just a toString? Or is there just like can I just grab the name? EQ. No. No. Oh no. So what is this? Type. Type is a syntax tree enum. All the possible types that a Rust value could have. Okay. So this is never paren path pointer reference. Is this a reference type? No. Is this a verbatim type? This is just a token stream though. I don't know. It's not a tuple. It's not a trait. It's not a slice. It's not a pointer. Well, okay, what does pointer wrap? Pointer wraps a const token mutability element. It wraps another type. So that doesn't get us anywhere. Path. Is this right? Is this what I want? Path seg. Is a type just like, for example, okay, so let me show you the type that I'm dealing with here. Is this type just a path type with no path? qself. Maybe. Type never. Type. It's not a macro. It's not an infer because that just tells the compiler to do something. It's not an impl. A type contained within invisible delimiters. What does this mean? What does this mean? Definitely not a bare function, and it's not an array type either. I'm gonna see. I'm just gonna assume that this is a path type path. Types 0. Let's go function get type name syn type. We're gonna borrow it and we're gonna give back a string. If let sim okay, so if this is a type path, then okay, let me finish this before I get too distracted by chat. So if this is a type path, then we're gonna grab the path, and a path is just these segments. Okay, so x.path.iter path.segments.iter path segment map x dot ident. We don't actually need a toString here, I don't think. And now what's fold called? I never remember. Rust vector fold. I just want to concatenate these, right? Sum. Can I? Let's try sum. Otherwise, Does panic, can I do like format specifiers in panic? I surely can, right? Handle this type. Cool. Okay, so, and get type name. The first type, the type is, well, let's start with the easy one. Let's start with, it's a U8, okay? It's a U8. So if it's a U8, then we just do this thing. We go quote, we just OR it together with this magical, so we're actually, I'm just gonna do these in line. We don't need these to be functions because we don't need to share these encodings and decodings anymore. Let's actually just grab this line properly. Excellent, excellent. Let me remember to put, let's just like, let's be very liberal with our brackets because that's good. Cool. So if it's a U8, one type in our discriminant. So this is this case, right? If we're pushing U8, we're encoding this as an instruction. We get the name of the opcode as an unsigned 16, and then we just take the value and we shift it into the upper 8 bits. Perfect. Perfect. Okay. Yeah. Let's just have a quick look at what people are saying. Lifetimes come along when you're dealing with structs that have references, exactly, right? So that I don't have complicated enough data for this to come up in this situation. You'd be reaching for print the name of the type of the thing to the console. Yeah, that's basically what I'm trying to do here. That's basically what I've ended up doing, right? Where I've had my best guess, but if it doesn't work, I'm just gonna dump it to the, you know, like when it blows up, it'll tell me what thing doesn't work. It'll give me some information about this type, and then I can infer what I need to do from there. Cool. Now, because of the order that these instructions are in, I'm actually gonna put my default case here. And we're gonna hit this panic, right? We're either gonna hit this panic or this panic. Okay, so let's try running this. Let's axe our encode. Yeah, so let's get rid of that impl for instruction. Let's axe it, it's gone, it's done. Okay, and then we're also just gonna clean this up a little. Get rid of this. Like that. Okay, so cargo build. Excellent. Unclosed delimiter, that makes a lot of sense because this needs the star thing there, I think. Okay. Now, let's have a look at this. Unnamed, that's because I didn't qualify this. Excellent, excellent. Okay. Unnamed. Sin, fields, unnamed. I think that's what it said it was. Expected string found unit. This is also very silly. I used a semicolon so it doesn't try and return the thing. Type cannot be formatted using debug. That's very annoying. How am I supposed to do this? You can't toString it. Oh, that's so annoying. Okay. Okay. But then I also can't do this, right? Oh, that's so annoying. What can I even do with this type? There's literally nothing that I can do with this type. That's literally no interesting methods. Print type. So is there like a type of? That surely doesn't work, right? I mean, I am in macro land. Print type of. I mean, this? Okay, let's try it. Let's try it. Any type name Thai. This is just going to say syn type, unfortunately. I don't think it's going to give me any details. Oh, sorry. Yeah, no. That's definitely not what I want. Okay, that's okay. We'll just see if we hit the panic. That unfortunately doesn't help. Like, I know what the type name is. I just don't know what the just what discriminant value or what variant it has. Sorry, I need to stop saying discriminant. What variant it has within the enum. That's what I want to know. If maybe missing an else clause. Where is this? 37. Oh, I need an else on this. And this again is just going to be a panic. Fields must be let's grab the variant name as well while we're here, because that's kind of cool. And we don't need a what am I need to stop running that. I need to stop minimizing to do that. Undeclared crate or module sim. Oh, yep, again. I can't read and write properly. Where is this? Sin. Good name. Good name. Okay. There's other fields in this. Nice. QSelf. Okay, so it has a QSelf. What was in this again? Sorry. Type path. Type. Oh. No. Path. Sorry, so the type path type is wrapped in a path variant. Excellent. And I made literally the same typo again. That's cool. That's cool. Okay. We can't sum like that. That's okay. Sum fold concat vector of string. How do I do this? Reduce, fold, fold. Can I do that? Does collect? Can collect actually do this? Is collect magic? Append. What are we doing? What are we doing? Nah. Yeah, collect will do it. Okay. Cool. I'm never sure how far collect will go. Cannot be built from... Oh, yep, okay. I do need a to string here, but that's okay. Let's... yeah, collect is a little bit magic. Okay, now cannot move out of this, which is behind a shared reference. Now this, we're gonna have to think about this more. Yeah, collect, I literally have no idea what collect does, but that seems to work. That's cool, that's cool. Okay. That is all on one screen apparently. X.ty is behind a shared reference. Okay, 37. Shared reference, type does not implement the copy trait. We're moving out of it. Enum variant unnamed. Behind a shared reference. which does not implement the copy tree. Okay, so there I can borrow. That one's easy to fix. Right, we just don't move it. I don't know if I can do the same thing here. I don't think a borrow really makes sense because the scopes are different. So what am I actually doing with this type? I think what this really means, because this isn't going to fix it. Okay, that fixed it. Never mind. Macro drive panicked. Fields must be unnamed invariant. Nope. That, of course, it was very silly of me, because there is a unit fields. So before I do all this field stuff, if let sin this, and like this is getting to the point where it should maybe be a match, but then there's an extra level of indentation. No, that's okay. So what we actually do here is this. Can you else if let? I don't know if you can. Okay, so that's good. This now just becomes a top level if. Okay, nice. So that just worked. That's insane. That means that we processed our NOP and we returned this. We processed our push instruction, we returned this, and then we hit this block. So let's keep fleshing this out. So let's go else if types len is 1 and get type name so if we get a register, then we're going to do a similar thing, but we're going to decode it differently. Encode it differently, sorry. Okay, so what does this function look like? Wait, where does U come from here? U. We just need to bring this back real quick. X. Yes, so actually, I need to change this. I need this entire thing to be here. I need to generate the entire left-hand side as well, right? Because I'm writing this and I'm like, wait, what is U, right? What I'm about to write R as U16. What am I doing? R as U16 and 0xf. I'm doing this. And I'm writing this and I'm like, hold on, but where does R come from? Well, R comes from here, right? U comes from here. But, so there's like, but then this is instruction. So we need to capture the things. And we can only do that if we know the, we can only do that if we know which types are there so that we know what to capture. So we have to generate the whole left-hand side of this as well. We can't just rely on this being down there, right? I hope that makes sense. And actually, instead of instruction, we're just going to write self, because that's nicer. And then we have to change fewer things when we come back and rename things later. Okay. Okay. So if we have one register, now this is going to be a really annoying condition to write, okay? And get type name. Sorry, this should be type 0. That was very silly of me. 0 register and get type name. Okay, so if they're both registers, then this has the value of quote, and let's even just copy this, R1, R2, okay, and the second register encoding looks like this. My god, this is disgusting. This if block has code smell. Oh boy, does it. Oh boy, does it. It's hard because I'm matching on two conditions at once. It's hard because I'm matching on two conditions at once. This needs to have an S. If I wasn't matching on two conditions at once, then I would know what to do. Wait, can you match on like an array? Can I match? Can I say, like for example, match S? Can I go like A, B? Can I do this? Is this illegal? Okay, once I've written this horrible expression, I might experiment and see if that works, see if I can refactor it, but for now, we are just going to do something so disgusting. R1, and then this is R2. Cool. Self-name, oh no, dude. Okay, so this is it. This is actually exactly what we need. And we just need to fix this as well, so it'll be self. This doesn't have any data that comes along with it, these ones do. And that will be everything. That's just gonna work, first time. First time, every time. Okay, what happens now? Expected a comma following a match arm. Isn't that what this is? Looks like pattern matching on slices. Okay, well it might be experimental, but that is pretty cool. That is pretty cool. That would make this look good, right? That's exactly what the problem is here. Okay, so why? Oh, I see what I've done. I put the comma outside the repeated pattern instead of inside it. Okay, now here we go. Dereference. This is hilarious. This is hilarious. I love that it has stuck this star in front of the type because it doesn't know where else to put it, I guess. Casting a register into a U16 is invalid. Okay, now what I need to do, I believe, is just put stars in front of all of these. There's no way that compiles. What is going on? That's amazing. But I guess the real test is, can I actually assemble a program? Get out of here. There's no way. That's amazing. Okay, that feels pretty good. That feels pretty good. Okay, so we'll just add this. We'll say generate instruction U16. Cool. Cool, cool, cool. Wait. We're writing this function twice. Let me just like double check that this actually runs and works. Okay, cool. Git. Cool. We'll just add that change in because it's better to clean it up. Okay, so And again, this is the kind of thing that can get completely factored out when we're generating this automatically, which is cool. And we can do the same thing. Okay, so let's clean this up. Let's see if we can clean this up. So there is this match on a slice. When is this question from? 2016. Is this still experimental? Match arms, expression without block, expression with block. Match arm. What is a match arm? Okay. I don't know. I would rather try and keep this clean. Let's start. Let's see what happens. Let's see what happens. Match. So actually, let's do another thing first. Let's map this to get type name, right? Because then this just gets even cleaner. This saves a lot of characters. Get type name. Cool. So that's nice. That's a little bit nicer, just straight off the bat. Okay, well, yeah, let me just write it. Types. So it'll be U8. It goes to this. Oh no. Oh no. I mean, I probably actually maybe just do this all on one line now. Like, I don't need to actually wrap what I'm quoting in curly braces. This is a bit unnecessary, but so be it. And then if it's even what can I turn a vec into like a tuple? No, that's mixing the type world and the value world in an unacceptable way, I think. And then we have the default case. I mean, maybe I just enable a nightly feature. That's probably okay. Invalid types. Yeah, okay. Oh, expect an array or slice, but if I just borrow this, then it becomes a slice, no? Consider slicing here. Oh, that's so annoying. Can I? No, okay, that doesn't work for type reasons. Is this really what I have to do here? Damon, save me. This just feels kind of silly, but I guess this works. Accepted string found stir. Except apparently I can't do this here. Can I convert? Hold on. Rust vec of string to slice of stir. Literally the first result. I love this. They have a different memory layout. Okay. Ugh. So I can't put my dots in here. I need this to be stirs. I need them to be stirs. as stir. Let's do it. Returns a reference to data owned by. Oh no. Yeah, because it's not, because a stir somehow depends on X, whereas a string is independent. Oh, this is, if I get this close and then it's disgusting to make this work, that's just so upsetting. That's so upsetting. Yeah, because they're heap allocated. I was disappointed with the lack of lifetime issues. Yeah, I shouldn't have said it. I cursed myself. Um, I cursed myself. So I've got, like, this is so close. This is so close. Okay. How do I get this? I just need to. It's like the golf ball is like on the lip of the hole. I just need to tap it in, but it feels like the only tool I have to tap it in is like a freaking driver. It's a rare sports analogy, by the way. I don't make those very often. Okay, okay. Like, this looks so good. This is so beautiful. I just have this problem where these are strings and I need them to be stirs. Can I return a stir here instead? Like, I certainly can't. I can't return a stir that depends on data that was passed into a function. Um, bazooka instead of driver? Yeah. Yeah. So, but, okay. I can't do this. I can't do this because, what if I do something really silly, right? A equals U8. I don't think I can match like this either because it's... I don't think this works either. Oh yeah, no, of course. But we can capture. But yeah, you can't match on a variable's value. I really want this to work because it looks so good. It looks so good. Like, it feels like we're writing Haskell or something instead of doing gross if else. Ooh. Okay, let's do it. Let's do it. Rust convert vec string to slice of stir. Give me whatever stupid expensive way to do it. Okay. Let's map this again. Oh, we don't actually... oops. I always forget, you don't actually need there's another place I did this, hold on. Where is it? Oh, never mind, I think I axed that. But yeah, if it's just, if you're just calling a function on the thing, you don't need to, where is it? Yeah, you don't need to give the thing a name even. Okay, as ref. Cannot be unsatisfied trait bounds. Here we go. Does not satisfy iterator. Am I calling this map? Can I not chain two maps in a row? Do I have to do something stupid like this? What's... Okay, well, let's also then try the other obvious thing, where we just wrap it here instead of adding another map step. Okay, that's fine because we can just borrow the string. That should be allowed. Can it return value referencing temporary value? Oh, okay. That's actually fine then. That makes sense. I understand what's happening here. Okay. To make this happen, I actually need... This is insane. I can't do this in place. I need a second vec. Well, actually no. I'm gonna make it a vec of stir, which is gonna be types dot iter dot map. And now we're gonna use the stir version of this. And that builds. There we go. So because of how asref works, we still need the data we're referencing to exist somewhere, so we need to have two vectors. This first vector has to exist. Otherwise, you know, like as ref, it's all in the name, it's a reference. What are we referencing? If we just try and reference this thing, well, once this map ends, it's just going to disappear. There's nothing kind of holding it in place. So we need a second vector. We need a second vector. Do we need to be as explicit about the types? No, that's good. And now look at how beautiful this is. Thank you, Damon, for a little push. This is lovely. This is so nice. Okay, and then we're gonna just like do the same thing again, which is kind of hilarious. We're gonna say let what are we saying? What are we saying? Let field U16 decodings. Right, we're basically going to copy and paste this whole block, okay? Because it's going to be very similar code. Very, very similar code. Very, very similar code. So we grab, we just have to turn it inside out. Okay? So each variant, we probably want to grab the value of it, because then we skip a step here. Okay, then we skip a step. So let's revisit our code. Let's just drop a marker here so that I don't have to do silly navigation. Let's find where we grab the values. Yeah. For adder. Okay. Otherwise, we just, yeah, cool. Okay, let me formalize this into a function. Get variant opcode value. Let's get rid of the word get. It's a little bit unnecessary. What do we pass in? V, which is a sin. Is it a variant? I think it's called variant. And this gives us back a U8. And we accidentally deleted something, so that's gone. That's gone. Also, I just overrode my my mark, so that's fine. We'll deal with that in a second. Okay, so variant opcode value. This is different. This is actually a different function, so that's good. That is very good. Value lit int parse arg.unwrap. So we have a lit int. Sin lit int. We can get the base 10 digits, and that's pretty good. We can get the base 10 parse, and that's also pretty good. And this gives us back a result n. So let's go let's even just see if we can no, match. Actually, I'm actually gonna have to go. I'm really sorry. This has snuck up on me. But this has been a fun stream. Thank you very much for tuning in. We've had some good progress. This is really coming together. Next time we're gonna finish this off, and then we'll be done with macros for a bit, and we can just add instructions and they're just gonna work. So sorry to go kind of suddenly. Thank you so much for tuning in. I'm Tom, and I'll catch you next time.